All right, folks. Here is an example problem. It's on page 109. It's 3.67. It is not one of the red numbers, so that means the answer is not in the back. But I thought this was a good one to prepare us to look at reactants and products, or the amounts specifically of reactants and products. So the first thing I'm going to do is read the question. It says ammonia, all right here, is a principal in nitrogen fertilizer. It is prepared from reacting hydrogen and nitrogen, both gases, if you notice. In a particular reaction, 6 moles, all right, here we see 2, 6 moles of NH3 were produced. How many moles of H2 and how many moles of N2 were reacted to produce those 6 moles? Well, this is just looking at molar ratios. And I'm actually going to plug in the mole ratio that we don't see here, which is nitrogen. So it's a 3:1 to 2 relationship. But what they're saying is they've produced 6 moles of this. I'm going to write it right above here. So now it's just looking at multiples. And as we talked about, your molar ratios can be smaller or larger than somebody sitting next to you, but it doesn't mean that you're going to get the problem wrong, as long as they're in proportion to one another. So it looks like 2 times 3 gives us 6. So as long as I multiply each of these numbers by 3, it's going to be in the same ratio. And they're asking for how many moles of H2 and N2. Well, that's an easy multiplication. You can do it just by looking at it. I'll show you how we can do it in a proportion. So there's 3 times 2 gives us 6, 3 times 1 gives us 3, 3 times 3 gives us 9. So originally they said it was a 2 NH3 to, I'll pick hydrogen this time, to 3 relationship. Well, let's use a simple proportion here. And they said, well, let's say you have 6 NH3s. The question is, well, how many? So I'm going to use an X of it should be H2. And again, these are moles. So I should probably write that here. This is moles. If I didn't write it here, then I'd take off points. So 2 moles to 3 moles of NH3 to H2, and 6 moles to X moles. So you'd cross multiply and get 6 times 3 is 18, 2x, get x by itself by dividing by 2, so 9 is equal to our x. So that's how we came up with that one. We would do the same thing if we wanted to find the N2. So that is a pretty straightforward one. The other one that I'm going to show you is also in the back of the text or back of the chapter. It is 3.74, and 3.74 is a little bit longer. Since towards the end of the section on the amounts of reactants and products, it is a harder one. So the question goes, for many years, the recovery of gold, that is the separation of gold from other materials, involved the use of potassium cyanide, this one right here. Cyanide, not a good thing. And they gave us the equation, and it's balanced already, which is nice. It's a pretty long equation. We actually have 1, 2, 3, 4 reactants and 2 products. It says, what is the minimum amount of this stuff, KCN, in moles needed? So in essence, we want moles. You can write question mark. We want moles of that to extract about 29.0 grams of gold. So how much of this do we need so that when it hits that gold, it will react and reform into this compound here? All right, so we have 29.0 grams. All right, so anytime we do a problem with grams especially, we're always going to use our periodic table. And our periodic table here is one right here. Periodic table, gold is a pretty heavy element. 1 mole is 196.96 or 9665, so I'll do 97. So if I know that 1 mole of AU is 196.97 grams. Okay, so that's one relationship. The other relationship I'm going to need is this 8 to 4 relationship. So we have 8 moles of KCN is related to 4 moles of AU. And then finally, we also should take the molar mass of this. Oh, but I see question mark moles. So if this said question mark grams, I would need the molar mass of KCN. But since it is not asking for it, we don't have to do that last step where we typically take the moles and turn them into grams. So here we go. So the first thing I'm going to do is say we're going to use our 29.0 grams of AU, put that over 1. All right, the next thing, since I have grams of AU, I should also put AU over here. I'm going to use that, so I'm going to say 196.97 grams of AU is 1 mole of AU. And then finally, I'm going to use my relationship here, since again, we want moles of KCN. So I'm going to cancel out my moles by using 4 moles of AU on the bottom for every 8 moles of KCN on the top. So I'm going to make sure my units cancel, so I have everything set up correctly. And I see that grams of AU cancel out with grams of AU, moles of AU cancel out with moles of AU. So when I multiply across, I get 29 times 8, and that is 232. And that's going to be in moles of AU. That is going to be divided by 196.97 times my 4. And that's going to give me 787.88. Remember, no units since we crossed everything out. And then finally, I'm going to take my 232, divide that by the 787.88, and it's going to tell me that I'm only going to need 0.29 moles of AU. Now, I see I have 3 significant digits there. I should really take this to 3, so it should be a 4 as well. So 0.294 moles of AU. So if you notice, let's review a little bit. Here is our given. All right, here's our molar mass of AU, so I'm just going to do MM. Here is our mole ratio. All right, sometimes called the bridge. And the thing that we did not have to do last was that molar mass of the KCN to figure out how many grams we needed. But if we did, we would just add that 4th column in there and figure out what 1 mole of KCN would be. All right, hopefully that helps.